It is a hot summer day, and you and your best friend each take out a cool can of soda from the refrigerator. As you open the can, you hear the reassuring fizz as it bubbles out a little. You both take a sip. Ah, that is good. Suddenly your mom calls you from outside. You are needed right away. You put your opened can on the counter and run out to her. However, your best friend, who aced her chemistry class, chooses to put her open can in the refrigerator before catching up with you. It was a smart move to put the soda in the refrigerator, but do you know why? Let us see what happens. 2 hours later, you come back inside and you need a drink. You pick up the open can of the soda you left on the counter and take a gulp. Not only is it warm, but it is flat. All of the fizz, which of course you know is carbon dioxide, has gone. Your best friend takes her open can out of the refrigerator, and she drinks some. Not only is it cold, as you would expect, but amazingly it is still fizzy. So how can we explain this? Why is there still carbon dioxide left in the cold can of soda, but not in the warm can? It is all to do with the solubility of gases in a liquid. Before we move on to looking at gases specifically, let us briefly remind ourselves of some important terms. A solution is a homogeneous mixture of substances. In other words, the solution is mixed in a uniform way. The substance that is dissolved is called the solute. The solute can be a liquid, a solid, or a gas. The solvent is the substance that does the dissolving. The solvent is usually in excess and can also be a gas, liquid, or a solid. Now we come across solutions all the time in our daily lives. Take, for example, this cup of tea. Here, the solute is the tea and the water is the solvent. Together they form a solution of tea. Another example of a solution is our can of soda. In this case, the solute is the carbon dioxide. This is dissolved in a solvent that is basically flavored water, to make the solution which is the soda. Solubility is defined as the maximum amount of solute that dissolves in a given amount of solvent. When a solution contains the maximum amount of solute, it is called saturated. Solubility is affected by three main factors. Firstly, the nature of the solvent and solute particles and how they interact together. Secondly, the temperature. And thirdly, the pressure of a gaseous solute. In this lesson, we are going to focus on the solubility of gases in a liquid. So that covers our first factor, which was just the nature of the solvent and solute. We will consider the effects of temperature and pressure in the next sections. Pressure has a major effect on the solubility of gas-liquid systems. At a constant temperature, raising the pressure increases the solubility of the gas. This occurs because increasing the gas pressure increases the concentration of gas molecules. To overcome this change and to maintain equilibrium, more gas molecules enter the liquid solution. This property is used in the soda-making industry. Sodas are bottled and canned under very high pressure of carbon dioxide, often as high as 4 units of atmospheric pressure or atmospheres. Once the can or the bottle is open, the pressure above the can opening is just normal atmospheric pressure, which is 1 atmosphere, 4 times lower than what is in the can. This then lowers the pressure inside the soda can. The carbon dioxide rapidly bubbles out of the soda solution. You see this effect when you first open your can of soda. A serious consequence on the effect of pressure on gas solubility is the painful, sometimes deadly condition called the bends. Scuba divers have to be very careful when they come back to the surface after a deep dive. This is because deeper water is at higher pressure than surface water. As divers breathe, more gas is being dissolved in their blood and other fluids. You already know that gases are less soluble at lower pressure. If divers come back up too quickly, the air that is dissolved in their blood bubbles out of solution. These bubbles can seriously affect blood circulation and nerve impulses. To help overcome this problem, deep-sea divers breathe a helium-oxygen mixture rather than compressed air, which is a nitrogen-oxygen mixture. Helium is much less soluble than nitrogen, and therefore less gas comes out of their blood when they come back to the surface of the water. Now we've seen how important pressure is on the solubility of gas in a liquid. The other really important factor to consider is temperature. The solubility of gases goes down as temperature increases. You have seen this yourself when you heat water in an open saucepan. Water also contains dissolved air. As you heat water, bubbles of air are formed. These bubbles of air are driven out of the water as the temperature goes up. The effects of temperature on solubility can also tell us why your friend from the beginning of the lesson still had fizz in her soda. By putting her soda in the fridge and keeping it cool, the solubility of the gas in the soda is still high. This prevented it from escaping the solution as quickly, so there was still fizz left. One smart friend, huh? But of course, temperature and solubility affect more than boiling water and keeping our sodas fizzy. One important environmental effect of temperature on gas solubility is the dissolution of carbon dioxide in the oceans. The ocean is a natural sink for carbon dioxide, which you can see in the carbon cycle diagram here. The oceans have absorbed many billions of tons of carbon dioxide from the atmosphere, because carbon dioxide is more soluble in the cooler temperatures of the ocean. Unfortunately, as the amount of atmospheric carbon dioxide continues to increase, the amount of carbon dioxide that is absorbed by the ocean is also going up. This has caused a significant change in the pH of the oceans. When too much carbon dioxide is absorbed by ocean water, it increases the acidity of the ocean. This change in acidity is caused by an increase in carbonic acid, which is formed as some of the carbon dioxide reacts with the water. This increase in acidity has an indirect effect on many of the natural chemical reactions that take place in the ocean. Unfortunately, this change in ocean chemistry has begun to have a major impact on the marine life that lives there. For example, you can see from this picture that the coral reef has been seriously affected by the acidity of the ocean. This example illustrates just how important it is to understand the factors that affect the solubility of a gas like carbon dioxide. In this lesson, you have learned that a solution is a homogeneous mixture of substances. A solution is made up of a solute that is being dissolved and a solvent that is doing the dissolving. You have also learned that solubility is a measure of the maximum amount of solute you can dissolve into a solvent. When this maximum is reached, the solution is said to be saturated. And finally, you have learned that the solubility of gases increases with increased pressure and decreases with increased temperature.